Welcome to the Nordic Venture Show, your speed date with the coolest ventures, brightest founders, and exciting things happening in the Nordics. In this episode, our venture date is with Clair Scientific, versatile automated microscopy.
Welcome to the deep dive. Today, we're really zeroing in on a specific piece of lab tech that's caught our eye, the Clair Z1 microscope from Clair Scientific.
Yeah, and you're here because, well, you want the inside track. Get smart on this quickly.
Exactly. We're aiming to give you that shortcut, really understand if this tool is genuinely, game-changing.
We've basically gone through Clair Scientific's own materials, their website, specs, the tech details, even some news mentions.
So our mission for this deep dive, figure out what makes this Clair Z1 tick. Is it really a significant step forward for, say, life science or nanoscience research?
What are those key innovations, the things that make it different? And crucially, how might that actually benefit you, the researcher, in your day-to-day work?
Okay, let's get into it. So the Clair Z1, they position it as, well, pretty versatile, right, for life science and nanoscience.
Covers a lot of ground. And the starting price, around 30,000 euro, that definitely makes you look twice for this kind of equipment.
It does. What about this philosophy they mentioned, achieve more with less?
Yeah, that's sort of their tagline. It suggests they're packing a lot of power and efficiency into something that's made more accessible.
Lowering the barrier, perhaps?
Potentially. Which leads nicely into the setup. They make a pretty bold claim here.
Oh, yeah. What's that?
Data ready in 10 minutes. Straight out of the box.
10 minutes? Seriously? Setting up a microscope usually takes, well, longer than 10 minutes.
Well, the thing is, it apparently comes pre-assembled. Optics, sample stages, the software, it's all supposedly good to go.
Okay.
And then they have these simple automated calibration routines. So the whole process seems designed to just work quickly.
Right. No fiddling with alignment for hours. That's appealing. And it's not just setup, it's physically fitting it in the lab, too.
Exactly. They say it's one of the lightest and most space-efficient automated microscopes out there.
Which matters, doesn't it? Lab space is always tight.
Always. So fitting on a standard bench, even potentially inside an incubator, that's a real practical advantage.
And no need for a separate computer screen cluttering things up.
Nope. It's got that integrated touchscreen. Pretty neat. No extra monitor, no keyboard needed.
Less clutter, more science. Always good. Okay, automation. That's a big buzzword. What can it actually automate?
Well, think about the really repetitive stuff. It's built for standard multi-well plates, 96 well, 384 well.
The bread and butter of a lot of biology labs.
Precisely. So it can automate scanning those entire plates, doing time-lapse imaging over hours or days.
Okay.
Z-stacking for 3D views, focus stacking, even scanning whole slides. Custom scans, too. It's meant to take that load off.
That does sound like a significant time saver. And what about controlling it? Can you do that from, your office?
Yeah, they mention a REST API, which basically means you can control it with scripts.
Scripts. So more complex experiments.
Exactly. You could potentially design and run experiments remotely, start scans, manage focus, handle the images and data, all through the network. It has a built-in Windows file share, apparently, so getting the data should be straightforward.
Interesting. So you could set up a long run and check in on it without being physically there.
That seems to be the idea. Big efficiency boost, potentially.
Now, it's designed for standard plates, but what if you use something different, like a petri dish?
That's where the customization comes in. They offer open-source designs for sample adapters.
Open source? Meaning?
Meaning you can download the designs and 3D print them yourself.
Rare.
Or modify them.
Ah, clever.
Yeah, and they mentioned users have already made adapters for petri dishes, slides, people looking at paint samples, fluid cells, all sorts of things.
So it's adaptable beyond the standard format. Okay, let's get to the core of it, the imaging. It does standard modes like bright field, phase contrast, DIC, but also this warp thing. What is warp?
Right, warp. Wavefront Angle Retrieval Processing. This looks like the real secret sauce here.
Wavefront angle.
Yeah.
Okay. Where does it come from?
Apparently it's derived from techniques used in X-ray microscopy and material science, so a bit different from standard light microscopy routes.
How different? Traditional methods look at light intensity, right? How much light gets through or bounces off.
Exactly. Absorption, scattering. But warp, it measures how the sample bends the light. The refraction.
Like the straw in a glass of water effect.
Precisely that kind of principle.
Yeah.
It's looking at the refractive index changes caused by the sample.
And why is that useful?
Well, it lets you see things that might be almost invisible using intensity alone. Really subtle structures.
Yeah.
And because different materials bend light differently, you can infer things about composition or density. It's like getting a different layer of information.
So not just if light is blocked, but how it's changed.
You got it. Plus, they say it can generate 3D thickness maps, height maps, and it works in full color.
Wow, okay. And you mentioned it does bright field, phase, DIC as well. Does it need extra bits for those? Filters and things?
That's the really clever part, it seems,
Yeah.
because that core warp measurement captures so much information about the light's interaction. It can computationally reconstruct those other modes. Bright field, phase contrast, DIC, all from the same single warp acquisition. No extra hardware needed.
Wait, so one scan gives you data you can then view as bright field or phase or DIC or warp?
That's what they claim. Every contrast mode is included in every measurement.
That's huge. That offers incredible flexibility after the fact, doesn't it?
Absolutely. You're not locked into one view. If you decide later you need phase contrast, you just switch the view in the software, presumably. They even list specific built-in modes optimized for different samples.
Okay, that warp technology sounds potentially very powerful. Now, this integrated everything idea, what does that mean practically?
It just means less stuff cluttering your bench. The touchscreen is built in, the user interface is on there. Even the processing power, it has an NVIDIA Orin platform inside, apparently, with like 2 TB of storage.
So the microscope is the computer, essentially.
Pretty much. Reduces complexity, reduces cables, reduces hassle. You get the live view right there. Control focus easily.
And software updates.
Over the air. So it should hopefully keep getting better over time without you needing to manually install things.
Like a smartphone, but for microscopy. Okay, maybe touch on some key specs quickly, just for context.
Sure. Standard lab operating conditions, 5 to 40 Celsius. Weight is about 5.7 kilos, so quite light. Dimensions are pretty compact, fits on a normal bench.
Power, network.
Standard AC power, gigabit Ethernet for the network connection. That integrated 7-inch touchscreen we mentioned.
How fast does it acquire images?
They quote things like 30 frames per second for video, maybe 0.2 FPs for phase contrast. And scanning a full 96 well plate takes about 4 minutes.
Okay, and image quality? Resolution.
It's a color CMOS camera, about 6 megapixels. Resolution depends on the objective, naturally. About half a micron per pixel at 10x, quarter micron at 20x, down to 0.12 microns per pixel at 40x.
Standard magnifications. Illumination. Focus.
LED illumination, full RGB plus white. Focus is motorized with autofocus, and it supports plates from 6 well up to 384 well, plus standard slides.
Seems pretty standard on that front, adaptable. So if a lab wants one...
Well, purchase starts from that 30,000 New York, excluding VAT, but they also offer rental options.
Rental, that could be useful for trying it out, or specific projects.
Exactly. And they estimate delivery within 10 working days, which sounds pretty quick for this kind of kit.
Very quick. Okay, lastly, has it been getting any attention, any buzz?
Yeah, it's popped up in some Danish publications, MedWatch and Burson. They highlighted some financial backing it received.
Good sign. What else did they say?
They described it as new and, interestingly, cheap, which, is relative in the world of research microscopes.
Relative to multi-million euro systems, maybe?
Right, but it underlines that accessibility angle again. And they note Clair Scientific is a startup founded by researchers for researchers.
That often helps people building tools they themselves would want to use. Okay, so let's try and pull this all together. What's the bottom line on the Clair Z1 from this deep dive?
Well, it really looks like a combination of that potentially powerful warp imaging tech.
Which gives you richer data, multiple views from one scan.
Right. Combined with serious automation, ease of use, that quick setup claim, a really compact design.
Saving that precious bench space.
And that surprising level of customization through the 3D printable adapters. It feels like it's targeting a lot of the common pain points in microscopy.
So for you, the listener, the potential benefits seem clear. Optimizing your workflow, getting rid of some repetitive tasks, maybe saving space and budget.
And critically, potentially getting deeper, more meaningful insights from your samples thanks to the way warp captures information.
Which leads us to a final thought to leave you with. With these kinds of advances in imaging like warp and instruments like the Clair Z1, making them perhaps more accessible, what does that unlock?
Yeah, what new questions can we ask? What discoveries, maybe in life science or materials that seemed out of reach before, might suddenly become possible?
Something to think about. How could a tool like this change your research?